Hi, this is Rick for EDU Mobile. In this discussion, we're going to talk about layouts, user interface layouts in Android. And these fall basically within two types, the linear layout and the relative layout. So let's get started. Android user interfaces, as we already know, we've seen this in a couple of cases, are specified in XML files. The layout XML is where we specify a user interface for an activity. The root node of the layout XML file is the layout container itself. And there are two basic types, linear layouts and relative layouts. Now, in older versions of Android, in older versions of the IDE, the Eclipse IDE and some other IDEs, it would give you a linear layout by default. But in newer versions, it will give you a relative layout by default. So what's the difference? A linear layout displays all of its children in a line, hence the name. That line is either going to be horizontal or vertical. It's a list of controls you can think of. Only one element can appear in any row in a vertical layout or any column in a horizontal layout. So we're somewhat constrained. And before relative layouts, we would set up a linear layout and then make other linear layouts inside of it and nest linear layouts to get the desired result. Well, a relative layout positions elements in relation to one another and also in relationship to the sides and the corners of the layout itself. So if we want a button in the middle of the screen, we can tell a relative layout, for example, to lay that button out, centering it horizontally, excuse me. So that's the basic difference between linear layouts and relative layouts. Okay, so let's look a little bit more at linear layouts in specific. Now, again, in modern Android development, we use relative layouts for the main container of the user interface, but linear layouts still have a use in fragments and also smaller portions of a relative layout. The linear layout's orientation is controlled by the Android orientation attribute. If this is horizontal, and that's the default, the controls in a linear layout will be laid out in one row and multiple columns. However, if it's vertical, they will be laid out in multiple rows, but only one column. So let's look at a couple examples. A linear layout, again, is organized like a list. There is only one row in a horizontal linear layout. There's only one column in a vertical linear layout. Two controls, in other words, and I want to specify this again, two controls may not occupy the same row in a vertical layout or the same column in a horizontal linear layout. So the little picture I have here, to the left is that of a vertical linear layout, and to the right is that of a horizontal linear layout. These are typically what these tend to look like. Now, there are margin attributes, as you may know, on every child in a layout. On every control there are margin attributes, and linear layouts will respect those. So the controls will be spaced out according to the margins, and it will also respect the padding between controls. It will also keep the alignment within each control. So if we have Android gravity equals center, then that control's text will be centered, let's say. Now, we can also apply a layout weight attribute to further control how the spacing between these user interface controls is going to be used up. So the weight of a control or an element corresponds to how much space each element will receive in the layout. Elements will expand in proportion to their weight. Now, you have to play around with this a little bit to really get the idea, but in the simplest case, it means that we can expand one or more elements to fill the remaining space. The element with the largest weight will expand to fill all the remaining area of the layout. So let's look at this. In this case, I have three controls. The first two controls have a layout weight of 1, and the third control has a lower layout weight of 0. the gravity on each control is set to Android gravity equals center. So the first two controls are filling out the space left by the third control, and they're filling it out equally. So even though the text in the first control says a control, and the text in the second control says another control, both of these controls will be spaced out to fill the remaining available space. And we see that the third control has in this case, let's say that third control had a hard set number of device-independent pixels set. Even though its text is not fully displayed, it still cuts it off so that the other two controls can have the remaining space. In a vertical orientation, let's say that we have three controls again. All three of these controls have their layout width attributes set to fill parent. In other words, the width of each control will be the same minus the padding and the margin of the parent, of the layout itself. But their height in the first case is set to wrap content, and in the last case is set to wrap content. But in the middle case, the layout height is set to 0 device-independent pixels. But since the weight of the middle control is set to 1, it will fill the remaining space between the other two controls. So this is how layout weight works. The top and bottom control have a height set to wrap its content. So the middle control has no choice but to fill the remaining space due to its weight being 1. Now, the second type of layout is a relative layout, and these become more important as we go forth with Android development. Relative layouts take the place of nested linear layouts when we need multiple rows and columns in a layout. In a relative layout, controls are positioned relative to one another, hence the name, or relative to the layout itself. So we have attributes like Android layout align parent top, Android align center horizontal, and many others to align a control within the layout itself. And we also have things like layout below or layout above or layout to left of, layout to right of, to align a control relative to other controls within the layout. So we can kind of see where this is going. In this layout, we could not really achieve this with linear layouts without doing a whole lot more work. Now I know this looks like a lot of work, but it's really not. The top control has an ID of title, and it is set to Android layout align parent top. Now these have Boolean values, align parent top true, and then the width is set to fill parent, so we can see how this is working. Now let's look at the next row in this layout, and let's look at the control on the left. That has an ID of ID edit text 1. It is set aligned parent left. It is set to layout below the thing with ID title, in other words, the first control on the screen. It is set to an Android layout to left of ID edit text 2, and its width is set to 0 pixels. In other words, it is going to fill, and it would fill remaining space if its weight were greater. The second control, the one to the left, or I'm sorry, the one to the right of the control we just talked about, has an ID of edit text 2. It is set aligned parent right to true. In other words, it's pushed all the way to the edge. It is laid out below the title. It is laid out to right of the edit text 1 control, and its layout width is 0 device independent pixels. Finally, at the bottom, we have an ID of button. It is set simply to layout with the align parent right and align parent bottom. And finally, it is set with a layout width of wrap content. And we may probably also set a layout height there of wrap content as well. The one thing I did want to mention with these ID fields is in these second two controls, we notice that when we are looking at another control, especially for the one to the left, When we refer to layout to left of, the one on the right may not have had its ID created yet, and so we use the plus there. Now, when that control refers to laid out below ID title, that's simply saying that without a plus, the title has probably been created before that. As we drag controls to a relative layout, these references will become kind of problems will arise between the references, and they will need to be corrected in the XML itself. So I just want you to be aware of that, and we talk about that a little bit here in the next slide as well. Relative layouts first are usually defined, especially if there are more than a little complex. They're usually defined in the GUI by dragging controls onto the layout and then refined in the XML file. So as I already said, in all but the simplest layouts, problems will arise in the relationships and the references between the controls that you'll need to correct in the XML. And as we go forth with relative layouts, you will see us doing this in the demos. Finally, a list of all the relative layout parameters, there are many, many of them, that are used in child controls within relative layouts is available at developer.android.com/reference Android widget relative layout.layoutparams.html. Thank you very much.